Hi, I'm Sarah Delicate, President of United Shoreline Ontario.
Hello, I'm Bernie Gigas. I'm with Loss Engineering in Rochester, New York.
Today's presentation is going to focus on Plan 2014's F-limit and why it needs to change.
We will be calling for an upstream and downstream balance.
So why are we still talking about Plan 2014 when we didn't flood this year? Well, we're going to look at the spring 2021 flood risk. So in absolute simple terms, when you have high Ontario Basin water supply and you add that to a high Ottawa River freshet, that gives you flood. So we already know Lake Erie is really, really high. When the upper Great Lakes are high, we have a very high likelihood that our basin water supply is going to be high. Ottawa River, nobody has a forecast for that, but it happened in 2017 and it happened in 2019. So we're not saying that there's any cause for panic right now, but we do need to plan. What can a regulation plan do for us?
Well, frankly, your regulation can do a lot, but it cannot prevent all flooding. We can flood and mitigate, and that's what we're going to be looking for.
So there are four things that we're going to be talking about today. The first thing is, how do the floods impact upstream and downstream differently? Second thing, how much extra water did we actually receive in 2019 upstream and downstream? Third, how does the F-limit react to this extra water and how does it redistribute the burden of the flooding? And our fourth and last is, what is it that we can do about this?
Okay, getting into this. How does the flooding impact upstream and downstream? Here's a quick geography lesson for the system. Bottom left-hand corner is Lake Ontario. Top right-hand corner is Montreal. The yellow line is the Ottawa River flowing top left towards Montreal, and then the St. Lawrence River flowing from Lake Ontario into Montreal. The region we're really focused on here today as an F-limit discussion is the region around Montreal. And so the next few slides are really going to be focusing in on this particular section. Here is a detailed aerial of the Ottawa River and St. Lawrence River confluence in Montreal. That's where they come together. We have Lake of Two Mountains on the north end, and we have Lake St. Louis on the southeast end of that, or southwest end rather. The Ottawa River flow comes from the top left-hand side, from Ottawa actually, through into Lake of Two Mountains and then splits. Part of the stream goes via the north end of Montreal, and part of it goes into Lake St. Louis, where it joins the flow from the St. Lawrence River. St. Lawrence River flow comes from the bottom left and joins the Ottawa River to mix the flow in Lake St. Louis. What's important to note here, in 2017 and 2019 flooding, the flooding that made it into the news, the flooding that had evacuations, significant flooding, happened in these red push pins. These are areas that flooded in 2017 and 2019. Notice that they are being inundated by Ottawa River water, not St. Lawrence River water. On the other hand, the push pins here, the 17 push pins here, which are on Lake St. Louis, which is directly influenced by St. Lawrence River flow, those regions most recently got themselves removed from the floodplains. So we have repeated major inundation of the northern section of Montreal by Ottawa River flow, and we have relatively little to no flooding in the region directly impacted by the St. Lawrence River. Now, I want to be realistic and I want to be reasonable here. The St. Lawrence River does have an impact on how quickly the Ottawa River can drain into Lake St. Louis and then out the other side of Montreal. I understand that. However, when we talk about flooding in Montreal in particular, we need to be sure that we talk about the Ottawa River freshet, not just the outlet out of Lake Ontario.
So Bernie, it seems to me that the next important question is, how much extra water did we actually receive in 2019?
Okay, so let's compare the net total supply on Lake Ontario. So that's the water from Lake Erie, precipitation minus evaporation, and the Ottawa River from April 15 to June 15. And I'll explain in a minute why that time period is so relevant. The gray line is the average net total supply for Lake Ontario. The blue line is what we actually received. So in 2019, Lake Ontario received 35% above average water, 2,834 cubic meters per second above average between April 15 and June 15. The Ottawa River average is here, and here's the actual 2019, same time period. The flow on the Ottawa River between April 15 and June 15, 2019 was 120%, more than twice the average. 3,735 cubic meters per second above average, which means the Ottawa River excess supplies were far greater than the Lake Ontario excess supplies.
So knowing that we had all of these incredible amounts of water, how did or how does Plan 2014 redistribute the pain of all these high water supplies?
Well, so that gets us into the F-limit discussion. The next agenda point is, how does the F-limit react to all this high water, and how does it redistribute the burden of flooding? So here's a plot. Many of you have seen this before. In yellow is the Ottawa River. In blue is Lake Ontario outflow, and in orange is Lake Ontario level. The region of interest here, the time period of interest, is April 15 to June 15 for three reasons. One, that's the period of the Ottawa River freshet. That's when the Ottawa floods. That's when you have high flow on the Ottawa River, or had in particular in 2019. The blue line shows how the Moses Saunders Dam is managed and how the F-limit causes the outflow from Lake Ontario through the Moses Saunders Dam to be cut back significantly, thereby raising the level of Lake Ontario by 30 inches or 76 centimeters in the 2 months of interest. That's the facts. Which now gets us into the rules. The IJC directed the board, the International Lake Ontario St. Lawrence River Board, to follow the 2016 Supplementary Order of Approval, which says, given supplies as seen in the past, that downstream, Montreal, shall not go higher than the quarter monthly average of 22.48 meters. That's criterion H3. It also says upstream, that's Lake Ontario, shall not go higher than these monthly average elevations per criterion H4, and they're listed there for the relevant time periods.
So Bernie, we just covered the fact that we know we didn't have supplies like we saw in the past. So knowing what happened, how did we do with balancing these two criterions?
Well, quite frankly, not that well. We didn't balance. You know, this plot's really pretty simple, right? The red region is H3. That is the region around Lake St. Louis, around Montreal, the duration and height above their limit, 4 centimeters, 4 weeks. The blue region, the much bigger blue region, is Lake Ontario per H4, 22 centimeters and 16 weeks. Upstream flooded 4 times longer, and upstream flooded 5 times higher than downstream. We did not balance at all. Plan 2014 fails to meet the binationally agreed requirements of the Supplementary Order of Approval.
So Bernie, let's do a quick summary of what we've talked about. The first thing that you covered, the major Montreal floods that required those evacuations in 2017 and 2019 were caused by the Ottawa River water and not the St. Lawrence River water. The second point you made is the Ottawa River received 120% more water in April and June of 2019, whereas Lake Ontario received 35% more water. The third piece is that Plan 2014 shifts the burden of all this excess water almost exclusively to Lake Ontario. Lake Ontario flooded 4 times longer than downstream. Upstream flooded 5 times higher than downstream. And according to the directive that the board has set the flows in accordance with the order of approval, but what we saw is that once criterion H14 is reached, which is that high level mark, that high level trigger, the board failed to adjust as required.
What can we do about this imbalance? What are we asking for from the board? Immediately, under deviation authority above H14, properly balance upstream and downstream interests by allowing the level of Lake St. Louis downstream to rise above the current upper limit of 22.48 meter in equal amounts that Lake Ontario is above H14. That's balance. Longer term, under adaptive management, modify the F-limit tiers to respect conditions H3 and H4 of the 2016 Supplementary Order of Approval.
So how can you help minimize the potential threat of 2021 flooding? Number one, share this video with everyone in your waterfront community, including the waterfront businesses. Number two, send this video link to your municipal elected officials. Ask them to pass a resolution requesting the same asks. We're providing you with a link to that resolution. Number three, send this video link to your state or provincial elected officials. Ask them to write the IJC requesting the same asks. We're providing you a sample template letter. Number four, send this video link to your federal elected officials. Ask them to write the IJC requesting the same asks. Again, we have provided you a sample template. And lastly, do it now. Nothing happens quickly, and we only have 5 months to influence the outcomes of 2021. So again, I'm Sarah Delicate with United Shoreline Ontario. Thank you so much for participating today.
Thank you again as well from me. This is Bernie Gigas signing up for Lost Engineering.